Welcome back. In our last session, we began our journey into science and technology studies by reframing science not as a separate, pristine enterprise, but as a deeply human and social one. We saw that even the most objective seeming scientific facts are in some way shaped by the social context in which they are produced. Today, we will take that idea one step further and introduce a powerful and sophisticated concept at the heart of STS, the co-production of science and society. For many, the relationship between science and society is a simple one. Science discovers truths about the natural world, and society then decides how to apply those truths. For instance, physicists discover nuclear fission, and society debates whether to build bombs or power plants. This is the simple linear view, which, as you know, does not hold true. The co-production framework rejects this clean distinction. Instead, it argues that science and society are mutually constitutive. They produce one another. Scientific knowledge and social order are not separate spheres of activity, but are in fact woven together into the same fabric of our world. The term co-production was most prominently developed by political scientist and STS pioneer Sheila Jasanoff. As she and others have argued, the co-production framework is more than a descriptive tool. It's a way of understanding how we, as a society, come to believe certain things about the world and, in turn, how those beliefs shape our social and political institutions. It's a lens for seeing that every scientific fact, every technical artifact, carries with it an embedded set of social norms, values, and power dynamics. Simultaneously, every social norm, every political structure creates the conditions for certain kinds of science to flourish while others wither. A feedback system that is based on co-production. Now, to fully grasp this, let's break down what it means to say that scientific knowledge and social order are co-produced. It's a two-way street where each element is constantly shaping and being shaped by the other. One side of the co-production coin is how scientific facts and technological innovations actively create new social categories, political institutions, and ethical dilemmas. Scientific knowledge is not just passively received by society. It's a powerful force that changes the world and the discourses within it. A classical example of this is the development of the internal combustion engine. The engine itself is a piece of technology, an outcome of scientific inquiry and engineering, of some tinkering with materials, and some happenstance that led to that particular development. But its co-production with society led to a complete reordering of our world. It created the social and political categories of driver and pedestrian. It demanded the invention of new legal frameworks like travel laws and traffic laws and the Department of Motor Vehicles and liability insurance. It created the need for vast new infrastructures like highways, gas stations, suburban developments, oil fields, which in turn reshaped our cities, our economy, and even our social lives. The internal combustion engine didn't just give us a new mode of transportation, it co-produced the modern automobile-dependent society that we live in today. Another powerful illustration is the realm of public health and genetics. The Human Genome Project, a monumental scientific effort that has taken place over the last 40 years, has co-produced a new social category and a set of new legal questions. We now have the concept of being genetically predisposed to certain diseases. This scientific fact has significant social implications. It raises questions about genetic privacy, employment discrimination based on genetic markers, and the moral status of embryos, for example. It has also led to new regulatory bodies, laws around genetic information, and even social movements that have to do with new genetic categories. The scientific knowledge of our genome and the social order that we live in are not separate. They are, on the contrary, profoundly linked. The other side of co-production is equally, if not more important, of course, that social norms Political priorities and economic interests are not external influences on science, but are fundamental to how science gets done. They shape which questions get asked, what is deemed good science, and who gets to participate in the scientific process. Consider the history of nuclear physics. The laws of physics related to nuclear fission are, in one sense, natural facts. However, the development of nuclear physics as a major scientific enterprise was inextricably co produced with a specific social and political order, the post World War II military and political imperatives of the Cold War. The immense funding and prestige poured into physics, the creation of national laboratories like the Los Alamos National Lab, and the institutionalization of big science were all co produced with the need to develop a nuclear arsenal and maintain a technological advantage over the Soviet Union. The Manhattan Project was not a purely scientific endeavor that happened to have political consequences. It was, from the very beginning, a political project from its inception, where the science itself was shaped and directed by the goals of military and political elites. The same dynamic is at play today in the field of artificial intelligence. The scientific research into machine learning algorithms is profoundly shaped by the priorities of Silicon Valley and the interests of corporate elites. The vast majority of funding and talent is directed towards building large language models and other forms of AI that have commercial applications, such as improving advertising algorithms, optimizing logistics, or generating content. The questions we ask of AI are, by and large, not how can we use AI to solve global poverty, or how can AI help us understand consciousness, but rather how can we use AI to increase profit. This is a clear case of social and economic priorities co-producing a specific type of scientific knowledge, leaving other potential avenues of research largely unexplored. The concept of co-production also helps us understand the very nature of expertise and the drawing of boundaries. In our last lecture, we touched on how scientists engage in so-called boundary work to separate what is science from what is non-science. The co-production framework shows us that this boundary is not a natural given. It is constantly being negotiated and produced by social forces. For example, who counts as a credible expert on climate change? Is it only the climate scientist with a PhD? What about the local farmer who has observed generational changes in rainfall patterns? What about the indigenous elder who knows centuries of ecological knowledge? The traditional scientific framework would draw a hard line privileging the academic scientist. But as societies become more fragmented and trusts in traditional institutions wanes, these boundaries become a site of intense political contest. This is a classic co-production problem. The authority of the climate scientist, a form of social order, is co-produced with the scientific facts about climate change. When that social order is challenged by political fragmentation and new forms of media, for example, the authority of the scientific facts themselves can be challenged. So, how does the concept of co-production relate to our central argument about the disconnection of elites and the troubles faced by science today? The golden age of post-World War II social contract for science was, in essence, a period of relatively stable co-production. Scientific elites, political elites, and economic elites were largely aligned around a shared vision. Science would be funded and its autonomy respected in exchange of delivering the technological innovations and military might that would ensure economic prosperity and national security. The co-production was coherent and generally worked. The fragmentation of these elites since the 1980s can be understood as a breakdown of the stable shared co-production. As political elites became more polarized and ideologically driven, and as economic elites became more fragmented and focused on short-term profits, they no longer share a common vision for what science is for. This leads to a situation where the co-production of science and society becomes erratic and contested. Science is no longer being co-produced with a unified social order, but with a splintered one, leading to the problems that we see today: political interference, public distrust, and a crisis of scientific authority and expertise. In our next session, we will put this co-production lens to work as we dive into the history of the post-war social contract and see how this era of elite alignment helped create a stable framework for science that would decades later begin to unravel. Thank you.